Welcome back to WAPSI. So we can go to a next section. Okay, here is the first question. Wire bound resistors are made by. What is meant by wire bound resistors? The resistors made up of wire. Okay, so first option is winding the wires of an alloy of germanium, augment and gallium. Okay, what is meant by germanium? Germanium is a semiconductor, so semiconductor can be used as a resistor. Okay, in the second option, winding the wires of an alloy of magnanin, constantin and nichrome. Okay, nichrome is a famous resistor which is used in bulb socket. And the third option is winding the wires of an alloy of copper, aluminum and silver. Okay, in here the copper is a perfect conductor. Okay, copper is a perfect conductor, so we can't use that as a resistors. And the fourth option is winding the wires of an alloy of silicon. Okay, silicon again another semiconductor, we can't use that as a resistor because we can only use the perfect metals. Okay, and the second option, winding the wires of an alloy of magnanin and constantin and nichrome. Yes, that option is the correct option. And the second question, 10 identical cells, each of potential E and internal resistance R are connected in series to form a closed circuit. Okay, an ideal voltmeter connected across 3 cells. Okay, that means the voltmeter only connect across a 3 cells. Okay, and what is the potential of one cell? E. For 3 cells it will be 3E. Direct question. So option number 4 is the correct answer. Okay, so we can move to the third question. If voltage across a bulb rated 220 volt, 100 volt drops by 2.5 percentage of its rated value, the percentage of rated value by which the power would decrease. Okay, the voltage get decrease by a value and we need to find what will be the decrease in, how much percentage of decrease happening to the power. So we need an equation which connect power and voltage. So P is equal to VI and we can change I. What is I? I is equal to V by R. Okay, so power is equal to V square by R. Since we are using this equation by because I is a variable quantity but R is a constant, so we are using the equation in which the resistance is in. Okay, that's why we use P is equal to V square by R. So power is depend upon the 2 times factor of voltage. So and the voltage is decreased by 2.5 percentage. So the change in P by P into 100 percentage will equal to 2 into change in V by V into 100 percentage, and change in V by V into 100 percentage is nothing but 2.5. 2.5 into 2 is 5 percentage. So 5 percentage of drop should be occurred to the power. That means option 1, first option, is the correct answer. Okay, so we can move to the fourth question. Okay, when a metal conductor connected to left gap of a meter bridge. Okay, left gap is connected by a meter bridge. Left gap is connected by a conductor inside that meter bridge. Okay, the balancing point when it is heating by applying an external instrument, and heat is given to the left metal conductor which is connected in the left gap of a meter bridge. Okay, what happens when we heat a metal? The resistance will increase. What happens if we heat a semiconductor? The resistance will decrease. So actually what is happening? The resistance is getting increased. So if this is the left gap and this is the right gap, okay, a balancing point is to be made initially by these 2 resistors. Okay, and actually we are increasing the temperature in the left will result increase in resistance in the left. that means the value of this left gap is increased. So in the ratio the contribution to the left is a large quantity. Okay, so when we calculate the ratio in the left gap, the ratio in the left gap in increase result, the length of the left gap will increase. That means, see, the options remains unchanged. That means the balancing point remain unchanged. Shift to the center, we don't know the we know the center, but we don't know whether the balancing point is the left or right. If it is the left, if it is shifting towards the center, it is correct. But if it is in the right, we can't say that it is moving towards left. Okay, because it is actually moving towards the right, and if it is in the right side, no, it is incorrect. So shift to the center is a partially wrong answer, and shift towards right is a perfect answer. So option 3 is the correct answer. Okay, then we can move to the fifth question, and the fifth question is, okay, a wire of certain material is stretched slowly by 10%. Okay, its new resistance and specific resistance become respectively. Okay, so by seeing the options, we can easily solve it. Okay, the first option is 1.21 times, that means the resistance is changing and the specific resistance is still the same. And in the second option, both remains the same. But actually, please think that if a wire is get stretched, its length will be changed, its area will be changed. Okay, then both remains the same is the incorrect option. Okay, and the third option is 1.1 times the resistance is getting increased, and 1.1 times as the specific resistance is getting increased. Actually think that the specific resistance, that means the resistivity will not change. It is a material property. For a same material, the resistivity will never change. And in the fourth option also the resistivity is changing, but it is incorrect. So only option 1 is the correct answer. But we can do this, we can prove this by theoretically. How the resistance get changed? By stretching a wire. Actually, we can say that the resistance is proportional to L square. By stretching, carefully heard that by stretching, resistance is proportional to L square. In normal case, R is proportional to L only. Okay, R is proportional to L only. But in case of stretching, it is proportional to L square. I will prove it that for you. That means, if L is the length of a wire and it is get doubled to L by stretching. Okay, specifically I is saying that by stretching. So the volume of the wire is in the cylindrical shape. So pi r square into L is the volume. Pi r1 square into L is the L1. L1 is L. So pi r1 square into L1 is the volume, and the volume is not changing. And the volume in the second case, pi r2 square into L2. L2 is what? Actually L2 is 2L, and the volume is not changing. So that means pi r1 square L is equal to pi r2 square into 2L. L and L get cancelled, and pi get cancelled, and r1 is equal to root 2 r2, or r2 is equal to r1 by root 2. Then the resistance is proportional to L and inversely proportional to area, and area is nothing but pi r square. So L by r1 square, and r2 is equal to L by 2L by r2 square. R2 is nothing but r1 by root 2. So we can change that to 2L by r2. R2 is nothing but r1 by root 2, and this root 2 will be here and it is square. Okay, which is equal to 4L by r1 square. See, R1 is L by R1 square and R2 is 4L by R1 square. That means R2 is 4 times the L1. So, R2 is 4 times the R1. Okay, that means 4 is coming from the factor square related to the 2. 2L, L get double 2, then the resistance get 4 times increase. Okay, so that's why we can say that R is proportional to L square while in case of stretching. Okay, then in case of stretching we can say that R1 by R2 is equal to L1 square by L2 square. Okay, which means L1 by L2 whole square. Okay, R1 by R2 is L2 is what, 110 centimeter, L1 is what, 100, so 100 by 110. Okay, therefore R2 by R1 which is equal to 1.1 square. Okay, because I just reversed, R1 by R2 is L1 by L2 whole square, so R2 by R1 is L2 by L1 whole square, and L2 is what, 110, L1 is what, 100, 110 divided by 100 is 1.1, 1.1 whole square is equal to 1.21. Okay, so that's why the first option 1.21 is the correct answer. Okay, this is the theoretical part, but in that time while you are attending the exam, you can choose by comparing the options also. Okay, so the next question, sixth question. A fully charged capacitor C with initial charge Q0. Capacitor is fully charged and the initial charge is Q0. Is connected to a coil of self-inductance L, self-inductance I at T is equal to 0. The time at which the energy is stored equally between the electric and magnetic field. That means half of the energy is given to the magnetic. That means the magnetic field is given by the inductor. So half energy is supplied to the inductor and half energy is stored in the capacitor. Okay, so actually we want to start from the fully charged capacitor. So energy is equal to what? The equation for energy in a fully charged capacitor is Q0 square by 2C. Okay, Q0 square by 2C is the energy stored in a capacitor. Okay, and half of that is used by the half of that charge is used by the inductor. Okay, then the remaining half part is used by which part? The capacitor. Okay, so the new charge, new energy E dash is equal to Q square. Okay, because after deploying some energy to the inductor, some charge only remaining inside the capacitor. That charge gives half of the energy which is initially the capacitor has. So Q is the instantaneous charge when the half of the energy is given to the inductor. So Q square by 2C is the E dash, that means the latest energy inside the capacitor. Okay, that is equal to half of the energy stored inside the capacitor when in the initial time. So half of the Q0 square by 2C, which is equal to Q0 square by 4C, and C get cancelled, and which is equal to Q square is equal to Q0 square by 2, that is Q is equal to Q0 by root 2. Okay, so when we check, the instantaneous charge is Q0 sine omega t is the instantaneous charge. That instantaneous charge is given as Q0 by root 2. So sine omega t is equal to 1 by root 2. So omega t is equal to sine inverse 1 by root 2. What is the value of sine inverse 1 by root 2? Nothing but 45. 45 means pi by 4. So omega t is equal to pi by 4. Actually we want to find omega or t. Read the question. Between the time at which you have to find the time. So time is equal to pi by omega 4. Okay, so we want to find what is omega. Omega, we know that omega is equal to 1 by root of LC in electronics. That means 1 by root of LC. Substitute in this equation, which gives time is equal to time t is equal to pi by 4 into root LC. See, pi by 4 into root LC is option 2. Option 2 is the correct answer, pi by 4 into root LC. Okay. So we can move to the 7th question. An alternating current is given by I is equal to I1 sin omega t. So I is equal to I1 sin omega t plus I2 cos omega t. I2 cos omega t. Okay, that means I is the component, I is the sum of sine function and cos function. When does the sine function comes to peak, there is a value of maximum value of sine is 1 and the maximum value of cos is 1. So we know that the RMS current, they are asked to find the RMS current. What is the full form of RMS? Root mean square. So after taking the square, find the mean value and take the root. Okay. So the maximum value of I1 sin omega t is just I1. The maximum value of I2 cos omega t is just I2. Just take the square on the both term. I1 square is just I1 square and I2 square is just I2 square. So to finding the mean value, just add these values and divide it by 2. So I1 square plus I2 square divided by 2 and taking the root. So which option is correct? Option A. First option is the correct answer. I1 square plus I2 square by 2 takes the root of all 10. Okay. Then we get moved to the 8th question. A series resonant AC circuit contains a capacitance 10 raised to minus 6 farad and an inductor of 10 raised to minus 4 Henry. Okay. The frequency of electrical oscillations will be, then we have to find the what's the frequencies. So what's the equation of frequency? Frequency is nothing but 1 by 2 pi root LC. Correct? Yes. Frequency f is equal to 1 by root pi into root LC. Here L is given, inductance L is equal to 10 raised to minus 4 and C is given 10 raised to minus 6. So LC is equal to 10 raised to minus 10. Root of LC is 10 raised to minus 5. So F is equal to 10 raised to 5 by 2 pi. Okay, which option is the correct answer? Option 1. So it's a direct question and the option 1 is the correct answer, 10 raised to 5 by 2 pi. And the main important thing is the equation for frequency in an LC circuit. Okay, that is F is equal to 1 by 2 pi root LC is the equation. Okay, just remember that equation only. So we can move to the 9th question. In a series LCR circuit, R is given, okay, L is given and the C is given and okay, the R is resistance is 300 ohm. Okay, R is 300 ohm, not 3909, and L is 0.9 Henry and C is 2 microfarad. Okay, microfarad means what? 2 into 10 raised to minus 6 farad. Okay, so value of L, C, R are all given and omega is what? 1000 radians per second. Okay, then we have to find the impedance. The impedance is the effective resistance acting in the circuit. So what's the equation for the impedance? Impedance is Z. Z is equal to root of R square plus XC minus XL whole square. Okay, what is XC? The effective impedance by the capacitor. What is XL? The effective impedance by the inductor. Okay, so we need to find XC and XL separately. XC is equal to 1 by C omega, which is equal to 1 by, what is C? 2 microfarad, that is 2 into 10 raised to minus 6, 2 into 10 raised to minus 6, and C is 2 into 10 raised to minus 6. What is omega? 1000. 10 raised to 3. That means 1 by 2 into 10 raised to minus 3, which is gives 10 raised to 3 by 2. 10 by 2 is 5. So 5 into 10 raised to 2. Okay, that is 500. So XC is equal to 500. What is XL? XL is nothing but L omega. L is 0.9. So 0.9 into 1000 is nothing but 900. So XL is 900. And the difference between XC and XL is 400. Square of 400, we have to take Z equal to root of R square. R is what? 300. 300 square plus 400 square. Okay, which is equal to we can take a 100 common. We can take a 100 common in here. 100 into 3 square plus 100 into 4 square, which is equal to root of 100 square into 3 square plus 4 square. Okay, the root of 100 square is 10. 10 into root of 3 square is 9, 4 square is 16, 9 plus 16 is what? 25, root of 25. Root 25 is 5, so 5 into 10 is 50. So the effective impedance in this circuit is 50. Okay, I think the option 1 has a symbol of ohm in here, and 400 ohm and 130 ohm and 90 ohm. Okay, and this is also ohm. Okay, last digit is the correction occurred due to the printing mistake. So the last digit is nothing but the symbol of ohm. So 50, first option is the 50 is the correct answer. Okay, you want to change the options like this, and you want to change the value of resistance as is into 300 ohm, not 3009 ohm. Okay, so R is 300 ohm and the option 1 is 50 ohm. Okay then, bye.